Hey everybody, so today all we're going to do is just go over yesterday's assignment. So we had a practice assignment over 7.3 yesterday. We started similar triangles, and I wanted to go over really quickly the three different similarities we covered. So with angle-angle similarity, you have to have two congruent angles in between your two triangles. So if you have two triangles, each one has a congruent angle or two congruent angles with the other, then the triangles themselves are similar. With side-side-side similarity, your side lengths are going to be proportional in between the triangles. So you need to have three pairs of proportional side lengths. With side-angle-side similarity, again, that's two proportional sides, and the included angle is congruent. So what that might look like if we have a triangle, two triangles, well, that is not very good. Oh well. So don't mark those congruencies. So we could have 12 and 8 and 6 and 4, and then we would have this congruent angle in the middle, making our triangles proportional by side, angle, side, or similarity. Okay, so getting started, we're going to look at our first example. So all of these were from our practice yesterday. With each set of similarity, we need to determine what information we're given to kind of base our testing off of. The thing with the similarities is you need to try out different things to see if the triangles are similar or not. Okay, so for our first triangle, we see that we have two angles in each set. We're asked to determine which triangle is not similar. Okay, so not being the key word here. And then I see that each of my triangles has two angles in them. So I want to look at my first triangle and say, okay, 50 and 92. In order to determine some similarities, I should probably know what my last angle measurement is. Okay, I know that a triangle is equal to 180 degrees. And then if I add these two together, these two angles here, I get 50 plus 92, which is 142 total degrees. When you subtract 142 minus 180, we're going to have a remaining angle measurement of 38 degrees. Okay, so now that I have my first triangle completely solved for, I'm just going to go and compare it to each triangle that's given. So I will color coordinate these for you. So anything that has a 50-degree angle will be red, any kind of 92 will be blue, and a 38 will be green. Okay, so by angle similarity, I know I have to have two congruent angles, okay, in between our two triangles. So here we have blue and green, next option red and green, and then our last one we have red, but this 82-degree measurement, we don't have any triangles that have an 82-degree measurement. So I know that triangle JKL is not similar to the others. Okay. Moving on, here we have to determine a true statement. So we have any two triangles are similar, any two isosceles, any two equilateral, and any two right. So based off of true statements, anytime you have an all cases situation, it's very complicated. We'll say complicated. Not all the time are any two triangles going to be similar. Okay, so if you think about it, you have maybe an equilateral triangle and then just pick a right triangle. These would not be similar, okay, because first off, equilateral triangles have 60-degree angles because they are angular, and then right triangles have at least a 90-degree angle. So I can automatically eliminate option A. Option B, we're looking at isosceles triangles. Okay, so I know isosceles triangles have congruent sides. Okay, so here we could have maybe 8 and 8, and then our other side lengths might be proportional. Okay, but the key with isosceles triangles is they have these congruent angles. So in order for our triangles to be similar, every side must be proportional, But also, if you look at the two angles, here we could have angle measurements of, say, 54 each. So each purple angle would be 54, but our green triangle might be 76. Okay, so we do not have angle-angle similarity. That would mean we don't have side-angle-side either. Okay, so option B is not going to be our answer either. Option C, we have equilateral triangles. We know equilateral means all of these side lengths are congruent. So if we have two equilateral triangles, it doesn't really matter how big or small they are, because we know that all three sides within the triangle themselves is congruent. If I were to set up my proportions, 8 over 15, 8 over 15, and 8 over 15, they would always be proportional. Again, it doesn't matter what the side lengths are, because when you compare your two sides between your two triangles, they will always have the same proportion. Okay, so here, this is a maybe, a very strong maybe, but let's check number option D. All right, if we have two right triangles, okay, so here we have a 3, 4, 5 triangle, and then here we might have a 5, 12, 13 triangle. So these are both special right triangles. Okay, so they are numerically accurate. They have our 90-degree angles included, so we might think, okay, side, angle, side. Well, let's compare. In order to have side, angle, side similarity, we have to have proportional sides. Okay, so set up your proportion. 3 over 5 equals 4 over 12. If I reduce 4 over 12, I have 1/3. Is 3 over 5 equal to 1/3? No. So in this situation, our right triangles, they may be, but if you have any two, it will not always happen. Okay, so our only option that is correct in any given situation would be C, our equilateral triangles. Moving forward, we have in this figure, VW and YZ are parallel. We need to find the value of X. So I'm going to circle X right here. Okay, so VW and YZ are parallel. Okay, so I'm going to draw those little parallel lines. If you're not sure how to set up a proportion, you can always think back to your parallel line transversal properties, those angles. Okay, so if we create a transversal here, we know that when two parallel lines are cut by a transversal, these alternate interior angles are congruent. Okay, so that means this blue angle here and this blue angle here are both congruent. So here we have this other transversal. Imagine the blue one is gone. We would again have alternate interior angles between our two triangles. And look which type of similarity we have. We have two triangles with two congruent angles. Okay, so that should mean that our proportions or our side lengths are proportional. Okay, so let's give it a shot. When we're setting up our proportions, you want to set up by the lines provided. So if I'm starting with my purple angles, we can say that x over x plus 4 equals, use the same exact order. So we started with our small triangle first, 7.2 over 12. Once here, you're going to cross multiply and solve for x. Okay, so we get 12x equals 7.2 times x plus 4. All right, that's going to simplify down to 7.2x plus 28.8. When we subtract 7.2 from both sides, we're left with 4.8x equals 28.8. And then dividing by 4.8, we are left with x equaling a total of 6. So when x is 6, these side lengths are proportional, and our triangles are similar. Okay? Moving on to number 4. Same thing. We're going to think, okay, I have these two right triangles. I'm given two side lengths, okay, and a set of angles. So in order for them to be similar, then I know that my angles have to be congruent. Okay, I have two sets of congruent angles, therefore my corresponding side lengths should be proportional. So I'm going to go opposite of my angles to make sure I'm putting up the right proportion. So 12 over 9 would equal, I started with my big triangle first, I'm going to go with my big triangle on the second. Okay, so y over 2, oop, that's a 3. Y plus 3 over 6. Okay, once we're here, we need to cross multiply. So we have 9y plus 27. Again, you just distribute that between both. And then 12 times 6 is 72. Solving for y, we need to get that isolated. So we have 45 equals 9y. And then last step, y will equal 5, or A. Okay, so if you wanted to classify this type of triangle, we would have angle, angle, similarity. Okay? Last example. Again, these little triangles we learned yesterday, remember, represent parallel lines. So this is very much like number 3. We have these parallel lines. Okay, if you can't identify the congruent angles, create that transversal. But to save a little time, I know that 3 and 4 are my proportional sides. 5 and 3.75 are proportional. And that is going to mean that if I have a congruent side, or proportional side, and angle, okay, then my entire triangle is proportional. So I'm going to set up that proportion. I need to solve for x. So I'll say x over the corresponding side 6.4 equals, and then it doesn't really matter which set you pick. You can either do purple or blue pair, but just pick both purple or both blue. I like purple personally, so I'm going to go with that. So I started with a 3 on top because that comes from my smaller triangle where x is. So make sure setting up your proportions, you have them in the correct order. So small triangle over a large triangle. Now that we're here, we just need to cross multiply again. 4x equals 19.2. Divide by 4, we have a value of 4.8, right, or C. So the biggest takeaway from 7.3 and similar triangles is to definitely set up your proportions correctly. Proportions are key, right? And then before you get started on today's assignment, I wanted to go over example number, I think it's 2. So you are going to have a triangle that looks something like this. Okay, there are 2 lines that are marked as parallel with the triangles. Okay, and you are asked to determine, is it similar, yes or no, and then if so, why, the reasons. Okay, we have angle, angle, similarity, side, angle, side, or side, 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 or not applicable. Okay, so we need to determine first, is it similar? Is it a similar set of triangles? And the reason, circle which one. Okay, in the assignment today, it's a drop-down box. So to go over how to do this one, remember parallel lines. If you need to extend them out to visualize it a little better, do so. Okay, we can create that transversal. And then look, if I was to rotate my triangle like this, okay, remember when we learned about parallels and transversals and we had these little window looking things of corresponding and consecutive and all of our different angle relationships. So here we're going to look at this angle here, which is in our small triangle, and this other corresponding angle in the quote-unquote big triangle, right? Anytime you have corresponding angles, okay, they sit in this top right corner of our grid-looking parallel transversal line set, Okay, these are congruent. Okay, so if I was to create another transversal over here, I have another set of corresponding angles. So here I have two sets of corresponding angles. Okay, they are both congruent in two different triangles. So I know that by angle-angle similarity, my triangles would be similar.